In this video, we're going to be taking a look at writing equations to represent situations, and you'll need to get out your Go Math book and turn to page 297, get out your math journal and a pencil. Now let's take a look at page 297. The essential question is, how do you write equations and determine whether a number is a solution of an equation? So before we take a look at equations and solutions, let's look at what an equation actually even is. So we can see an equation is a mathematical statement that two expressions are equal. An equation may or may not contain variables. For an equation that has a variable, a solution of the equation is a value of the variable that makes the equation true. So let's take a look at that box on page 297. So we can see the expression, a numerical expression, would be 5 plus 4. So that's just an expression. Now the equation we can see is 5 plus 4 equals 9. Remember, an equation represents a relationship between two values. So 5 and 4 equals 9, and also 9 equals, 5 plus 4 equals 9, and then 9 also equals 5 plus 4. So let's take a look at expressions written as words. A number plus 4, equation, a number plus 4 is 9. Okay, so you can see an equation, easy way to remember that, an equation will have an equal sign with it. So algebraic expression, n plus 4. Algebraic equation, n plus 4 equals 9. That means the value of the variable plus 4 will equal 9 with that. Okay, so let's take a look at example number 1. It says determine whether the given value is a solution of the equation. Remember, the solution of the equation is the value of the variable that makes the equation true. So we have x plus 9 equals 15. Now if x equals 6, will that be a solution? So I can just replace my variable with 6. 6 plus 9 equals 15. Obviously 15 equals 15. So we can see 6 is a solution of x plus 9 equaling 15. Because if I plug in 6 for the variable and add 9 to it, it will give me 15. If I were to say 5, that would not be a solution, but 6 would be a solution for that variable. Now let's take a look at letter B. We have y divided by 4 equals 32. Now y, let's say that y equals 8. So the value of y is 8. So 8 divided by 4, does that equal 32? We can see here, substitute 8 for the y. So we know 8 divided by 4 is 2. So 2 does not equal 32, obviously. So that would mean that 8 is not a solution of the equation y divided by 4 equals 32. Let's take a look at letter C. We have 8 times x equals 72, and x equals 9. Now let's replace that x. We're going to substitute 9 for the x, so 8 times 9. Does that equal 72? We multiply 8 times 9 gives me 72. Obviously 72 equals 72. So 9 would be considered a solution for 8 times x equals 72. For example, 3 would not. Why would 3 not be considered a solution? Because 8 times 3 is 24. That obviously does not equal 72. Let's take a look at the next page. Page 298. I would like you to turn there. Now let's take a look at number 1 together. We can work this out together. So we see determine whether the given value is the solution of the equation. So we have 11 equals n plus 6. So let's substitute, and then the variable n equals 5. So we have 11 equals, and then we're going to substitute the n with 5. 5 plus 6. Now we can add 5 and 6 together. First of all, we can drop down that 11, drop down the equal sign. 5 and 6, that gives me 11. So you can see, since adding 5 and 6 together equals 11, we could say yes, that 5 is the solution for the equation n plus 6. Let's take a look at number 2. we have y minus 6 equals 24, and then the value of y is 18. So we have y minus 6 equaling 24. So first of all, we're going to replace that variable y with 18. So we have 18 minus 6. Let's write it out. Let's say equaling 24. So first of all, we need to subtract 18 minus 6. That gives us 12. Obviously, 12 does not equal 24. We would say that 18 would not be a solution for y minus 6. So we can write no for number 2. Now I'd like you to work out number 3, and you can work on that now. So you can see number 3, yes, that is a solution, because when I replace that x with 36, 36 minus 9 equals 4. Now let's take a look at number 4. I would like you to work on that now. Now we have 5 times t giving us equaling 100, and t, the value of t is 6. So we have 5 times 6, that's going to give us 90. That obviously is not equal to 100, so 6 would not be a solution for 5 times t equaling 100. Now let's take a look at writing equations to represent situations. On page 298, it says you can represent some real-world situations with an equation. Making a model first can help you organize that information. So let's take a look at example number 2. So it says Mark scored 17 points for the home team in a basketball game. His teammates as a group scored P points. It's going to be the variable. Write an equation to represent this situation. So we can see from this, so Mark's points 17 plus the teammates' points, we can see right here, the variable it's given to us, plus P equals 46. Why do we know it's 46? Because the home team, we can see the score right here, 46. So we can see that the equation would be 17 plus P equaling 46 based upon that situation. Now let's take a look at number 5. We'll do some of these together. So it says Marilyn has a fish tank that contains 38 fish. There are 9 goldfish and F other fish. All right, so what we need to do, first of all, we need to think about what type of operation we're going to work through. Okay, so if we know that the fish tank contains 38 fish, we know that there are 9 goldfish and a certain amount of other fish. This seems like an addition problem. So I know that there are a total of 38 fish, so that's going to be my answer in an addition problem. So we know that there are 9 goldfish, so we have 9 here, plus, and then the variable F will be part of my equation there. So 9 plus F equals 38. So Marilyn's 9 goldfish plus a certain amount of other fish equals a total of 38 fish. Let's take a look at number 6 together. Now we have Juanita has 102 beads to make N necklaces. Each necklace will have 17 beads. So what we need to do is we need to figure out how many necklaces she can make. Okay, so we know that each necklace, she has a total of 102 beads. Now we know also that she has 17 beads. So this is going to be multiplication. So 17 times N. So each necklace will have 17 beads. We don't know how many necklaces she's going to make. So 17 beads times the amount of necklaces that she'll make will equal a grand total of 102 beads. Let's take a look at number 7 together. Craig is a certain amount of years old. His 12-year-old sister, Caitlin, is 3 years younger than Craig. So let's take a look at this situation. All right, so we know that his 12-year-old sister is 3 years younger than Craig. So we do not know how old Craig is, but we know that his sister is 3 years younger. So we can take the age of Craig, subtract 3 years from that, and we know that Caitlin is 12 years old. So we can represent this situation as C minus 3 equals 12. The unknown value, or the unknown age of Craig, minus 3 years will give us the age of Caitlin. Now I want you to take a look at number 8 and try this one out by yourself, and you can work on that now. Okay, so you should have the equation is 2 times h equals 8. Now let's take a look at page 299, saying write an equation and checking solutions. It says you can substitute a given value for the variable in a real-world equation to check if that value makes sense for the situation. So you can take a look at example number 3. It says Sarah used a gift card to buy $47 worth of groceries. Now she has $18 left on her gift card. Write an equation to represent the situation. So we've done that already. That type of task already, I should say. It says use your equation to determine whether Sarah had $65 or $59 on the gift card before buying groceries. So you can see the equation that was written, x minus 47 equals 18. And this part of the lesson is just either using 65 or 59 to substitute for that variable. So if you have 65 minus 14, does that equal 18? Or 65 minus 47, does that equal 18? Or does 59 minus 47 equal 18? So you subtract those two variables, or those two amounts, substitute for the variable. You can see 65 minus 47 gives us 18. 59 minus 47 does give us 12. So you can see the answer, the amount on Sarah's gift card before she bought groceries, was $65. Now let's take a look at this next question. It says suppose Sarah has left $12 on her gift card. How would this change the equation and the final answer? So the equation would be x minus 47 equals 12, and the original amount then would be 59 if it was $12 left. Now let's take a look at number 10 together. We'll work this out. It says on Saturday morning, Owen earned $24. By the end of the afternoon, he had earned a total of $62. Write an equation to represent the situation. So that's our first step. So we know Owen earned $24. So we know that. And then by the end of the afternoon, he had a total of $62. So 24 plus a certain amount, we don't know, will equal a total of 62. Now we need to figure out, did he earn $38 or $31? So we can see 24 plus, let's see, 32, plug that in. I'm sorry, 38, plug that in. 24 plus 38 is going to give me 62. And then if I were to plug in 31 for the variable, 24 plus 31, you can see that equals, 55. Got a little brain dead there. Okay, so we can see that the sample equation is x plus, or 24 plus x equals 62. And then did he earn $38 or $31 on the Saturday afternoon? We could see $38 would be the answer for that second question. Okay, I want you to now to work on number 3 on page 300, and you can work on that now. Okay, for number 3, yes, that would be a solution. Now I'd like you to work on number 15 on page 300, and you can work on that now. Okay, the answer for 15 is 8 times x equals 208, and $26 would be the ticket cost. Now let's jump down to number 17. Tell how you can determine whether a number is a solution of an equation. You can substitute the number for the variable and simplify. If the final statement is true, the number is a solution. So this concludes the video on writing equations to represent situations. If you have any questions about this concept, please come and see me.